Good morning. Now, this is class 2 of the chapter electricity. Now, in this, we'll learn about energy consumed by electrical appliances. This is very simple. You can just go through it, you can just read it. Okay. So, you know that in your home you might have got various electrical appliances, and but their energy consumption will be different. That is, some equipments will consume more power, and so your electricity bill will become high, and whereas some other equipments use less power, and so there will be considerable decrease in your electricity bill. So depending on the consumption, your electricity bill will vary from month to month. So therefore, a proper energy management by knowing and controlling the use of such appliances is very important for your monetary benefits and also for the sake of the environment. Now here are a few of the steps that you will have to follow while calculating the energy consumed by an electrical appliances. One is determine the power rating, which is usually given in watts, of each device. You have to know the power rating of each device, and most devices will have a label showing its power content. You might have seen that in refrigerators and all, certain 5 stars, 3 stars and all are will be there. So this is actually the power rating of this device, so that know about the power rating of the each and every device in your home. Next is calculate the daily consumption of power by each device by knowing the number of hours it is used in a day. Then convert watts to kilowatts, that is by dividing watt with 1,000 you will get that. Then determine the kilowatts each appliance use in a month. Then knowing the electricity tariff at your place, you can calculate how much each device costs you in a month. So this actually gives us an idea about the energy consumption of each and every devices in your home. Hope you understood. It's just nothing to study well. It is just you can go through it. Okay, that is enough. Now, power consumption by electrical appliances can be done in a fairly simple way, except for some devices like iron box, refrigerator, washing machine, air conditioner, etc. The above excluded appliances switch on and off intermittently, and hence the calculation of energy consumed by these appliances is complicated. That is, for certain devices, you can calculate the energy or power consumed by using the following above mentioned steps. But whereas for these equipments like refrigerator and all, they actually switch on and off intermittently. That is, in between they will switch on and then it will automatically start. So it is very difficult to determine the energy consumption of such devices because they are switching on and off intermittently. Okay, so their energy consumption by these appliances is difficult to predict. Now, power is always represented in terms of watt or kilowatt. 1 kilowatt is 1000 watt. Electricity bill in your home usually comes in units of kilowatt hour. Kilowatt hour is actually the billing unit for energy delivered to consumers by electricity suppliers. What is 1 kilowatt hour? It is actually a one called 1 unit of electricity. It is nothing but total energy consumed in kilowatt hour by an appliance or by a number of appliances together is equal to total power in kilowatt multiplied by time in hours. That here there is an example. You have a 1 horsepower water pump. Suppose that it is operating for 1 hour and it consumes 0.746 kilowatt of energy. Okay, then a mixer grinder, it consumes 400 watt and it is operating for 1 hour. Then how much energy will it consume? It is about 0.4. Similarly, you can calculate for each of the devices, and we can say that an LED bulb, it consumes less power when compared with a filament bulb. Now here, the total energy consumed in a day at your home will be equal to power of light bulb into hours it used plus power of fan into hours it used plus power of TV into hours it used plus power of fridge into hours it is used plus power of phone charger into hours it is used plus etc. This is how you can calculate the total electrical energy consumed in a day at your home. That is, you might have got various devices, so understand the power that is consumed and then multiply it with the hours it is used. Then you can add this for each and every equipment and you will get the total energy consumed in a day at your home. Suppose that you get a total energy as 3500, that is 3.5 kilowatt or 3.5 units of electricity is used per day. That is, in Kerala, electricity bill normally comes in every 60 days, and if you divide the total energy total consumed energy given in the bill with 60, then you should get a number very close to what you calculated per day. Now, a practical method to see the power consumed by each appliance is to first switch off entire electrical appliances. That is, you switch off all each and every appliances in your home and look at the energy meter in your home. Then, it in the appropriate mode by pushing the switch on the meter. This is how you set the meter. That is, push the switch on and then look at the meter. The meter should show approximately 0 kilowatt hour. Then if the meter is reading not approximately 0, then either the wiring or the meter in your home will be faulty, that is, it will be defective. Then in that case you switch on each appliance. After that, then you switch on each appliance one by one and see the meter reading. So first you switch off all the appliances, then you go to the meter, push the switch on the meter and look at the meter reading. And after that you switch on each and every appliances, then the meter will show the readings. In the electronic meter there is a small push switch next to the display. You have to press the switch several times until you see the unit kilowatt hour, and you have to read the numbers in the units. That is, you are switching off the appliances, then you go to the meter, then push the switch on the meter, and the meter will then after that you have to switch on the appliances, and finally you can see the reading in the meter. This is how you read the energy consumed by your appliances from the meter provided by KCB. Now most devices have a label showing how many watt it uses, and this is just a table showing that each and every device. There's no need of by hearting all this, just have a look, that's enough. Okay. Now, the actual power consumed by appliances such as iron box, refrigerator, washing machine, AC, etc. cannot be calculated directly from its power rating. Why? This I have already told the reason why. Because these devices will switch on and off intermittently, and so it is difficult to understand the actual power it is consumed. But in some appliances, you can see that instead of that, since that method is not possible, the manufacturers themselves provide a star rating for these devices, rating from 1 to 5. Okay. Now, a simple explanation is that higher the rating, the greater will be the efficiency. If it is 5 star, then its efficiency will be high. If it is 4 star, its efficiency will be less when compared to that of a 5-star rated device. Okay. However, it is very complex to explain in detail because the rating criterion is different for different appliances and also for the same appliance. Okay, so a refrigerator that got 5-star in a year may get only a 4-star in the next year. That rating may vary from year to year. Okay. The next one is normally appliances with higher star rating cost more. That is, a device with higher star rating will be highly efficient, and that's why its cost will also be high, and hence the choice will be very difficult for a normal consumer. That is, for example, if you there is an example given here. Suppose you want to buy an AC, and if you got for more efficient, energy efficient 4-star AC, then it will cost much more than without a 2-star, which is less efficient. So that is the difficult. That is, if you want to get a more efficient one, you will go for a device with more star, but its cost will be high. So for a normal customer, it will be difficult to buy such high rated devices. However, high efficient device which actually reduce your electricity bill, that is a merit. Anyway, a star rating should be used only to compare exactly identical products. For example, a 4-star refrigerator with a capacity 165 liter should not be compared with a 300 liter 3-star one. That is, if you are going to compare, you must compare the device with the same star rating. Okay. So if you go for a high star device, its efficiency will also be high, and it will reduce your electricity bill, but its cost will be high. Next important session is transformer. This is an important session. So the other one you just read through. You will understand it. Just understand it, and then study the definitions for kilowatt hour and all. Now this is an important section, transformer. What is a transformer? It is an electric device which transfers electrical energy from one circuit to another circuit without a metallic physical contact between the two circuits, making use of electromagnetic induction. So it's nothing but a device which transfers electrical energy from one circuit to another circuit by making use of the principle of electromagnetic induction. In lower classes, I think you have studied about these transformers. Okay. In simplest form, a transformer consists of two coils of wires wound around a ferromagnetic material called iron. Now, the coil on the left side with n number of turns is called a primary winding, and the coil on the right side with the n2 number of turns is called secondary winding. So the coil on the left with n1 number of turns is a primary, and the coil on the right with n2 number of turns is the secondary winding. Now using Faraday's laws of induction, you have a formula v1 v2 by v1 is equal to n2 by n1. Now it means that if n2, what is n2? Secondary winding, number of turns on secondary coil. Okay, if n2 is greater than n1, then output voltage, that is v2, will be greater than v1. Quite natural. And such transformers are called step up transformer, and the opposite one is the step down transformer. So you have got two definitions: what is a transformer, what is primary winding, secondary winding, what is step up and step down transformers, right? Now, according to law of conservation of energy, for an ideal transformer, the power in primary should be the same as power in secondary. That is, power is current into voltage. So here power in primary, that is I1 V1, will be equal to power in secondary, that is I2 V2. Thus, by using a step up transformer, we can decrease current in the secondary. How? By increasing voltage in secondary. But however, there is always some loss in a transformer. So in such cases, less than that in primary. So this is a schematic diagram. See, this is the primary. Okay, this is the secondary. This is iron core over which the coils are wound. This is a schematic diagram of a transformer. Now, normally electricity is produced in remote places, and it has to be transmitted over large distances before reaching the consumers, right? Once electricity is produced, it has to reach the customers, right? So transformers are used to increase voltages before transmitting electrical energy over long distances through wires. Wires are usually made of aluminum. So in order to increase, or in order to step up voltages before transmitting this generated power to the consumers, we use transformers. Okay, now wire has certain resistance which results in loss of energy. Any metal that has got resistance, when current flows through it, there will be loss of energy according to I square R loss. Okay, now we have seen that current I will be less when voltage V is increased using step up transformer, as already told. Thus, by stepping up the voltage, we can reduce current and hence a lower transmission loss. So how can you reduce this transmission loss or heat loss? By using a step up transformer, because a step up transformer, it step up voltage and thereby reducing current, hence there will be a lower transmission loss. Now, before supplying electricity to individual consumer, the voltage is stepped down using a series of transformers at the distribution stations and thereafter. Okay, the typical generator voltages are given here, and the use of transformers reduce the transmission loss over long distance by keeping the voltage high. This is the high voltage transmission data in Kerala. No need of by hearting, just go through it. The major contribution factor to this transmission loss is the finite resistance of aluminum wires. Copper is better conductor than aluminum, but since copper is highly costly, it is not commonly used. Instead, we use aluminum. Now, another added advantage of aluminum over copper is that aluminum has only half the weight, but copper is heavy. Now, in order to increase the physical strength of aluminum transmission lines, steel reinforced aluminum cables are used nowadays. Okay, in which a few strands of galvanized steel wires are used as core, over which aluminum wires are wrapped in spiral shape. That is, we use here some galvanized steel wires. It is used as the core, that is central part is used as the galvanized steel wires are used for the central part, and over that we wind what? Aluminum wires. And this winding is done in the form of a spiral shape as shown in this figure. So here that's all for today. Here the important session is about transformers. The other one, that is electrical power consumption by appliances and all, just go through it. That is enough. Okay, that's it. Thank you.